Hi guys, have you ever seen those magicians? You know the ones where they got 3 cups and they put a ball underneath and they start moving them around and you're standing there like that, trying to follow, and they're moving them like that, and then you pick one and he lifts it up and it's not there. And you're wondering, how did he do that? Well, it's kind of the same when it comes to triangles and trying to work out which ratio is involved. Like you look here, you look there, which one is it? Is it a cos? Is it a tan? Is it a sine? Is it none of them? So here's something that I'm going to make a point now on how you can actually discover which ratio is involved. And the point is this: it's all about pointing. Physically pointing, because so often we just stare at what's happening, but then if we take our finger out, we're physically involved and we're pointing, and maybe we can follow better than before. So that's what we're going to do for this example. We're going to point out which ratio it is. So first of all, the clues are in the question. So let's start pointing here. So we have A that we're looking for right here, that length there. Now that's kind of like, what is it from the angle? The angle is 61:15 minutes. Over that way, right? Now it's kind of like which way we're pointing now. It's opposite, right? Now over here below the angle, right next to it, as I'm pointing, is adjacent, isn't it? Right over there. So what do we have? We have opposite and adjacent. So let me just mark them out. We have that opposite and we have there adjacent, right? So let's write out that ratio simply out of the pointing we've just done. So it's going to be opposite over adjacent. Okay, that's the hardest part. Once you get the ratio, then the rest is easy. So now that we have the ratio, opposite over adjacent, which one is it? Sine, cos, or tan. If you remember from SOHCAHTOA, katoa, that's opposite of adjacent, that's the toa part, that's going to be a tan, is it? Tan is opposite over adjacent, it's the toa part. So tan theta equals opposite over adjacent. So let's take these and substitute them in there and then solve the equation and work out what the missing pronumeral A is. So let's go through the process. Now tan theta, well that's 61 degrees 15, isn't it? So we go tan 61 degrees 15 minutes equals, and the opposite is the missing pronumeral. So let's write that in. A all over the adjacent length right across there, 13.5. Okay, let's multiply by both sides by 13.5 times by 13.5 to get the A by itself times 13.5. Okay, so this side is going to be just 13.5 times, again, now tan 61:15 on the calculator is going to yield 1.43. And remembering when we put it into the calculator, we press 61 degrees, which is DMS, and then 15 degrees DMS again, and it automatically works that out depending on your calculator. So that's 1.43, and that equals, all by itself, A. Okay, let's bring the A over to the left and that to the right. A, the missing pronumeral, is 13.5 times 1.43. Pressing that on the calculator is going to give us the final answer for the pronumeral length there is 19.37, and always remembering the units, we have centimeters.